So to really understand what our virtual users see, I think it's helpful to get some understanding of just how our backend looks like and some of the information that we're collecting, especially as we go into these derived data sets or crawling data sets. It's helpful to understand what the basis for those are. So when you visit a web page, in this particular case, we have a screenshot of PassiveTotal.org on the screen. What you're seeing here is an application that's been rendered for you. What you may not have seen is that there were hundreds of web requests that took place and a number of different actions that helped construct the application that you're interacting with. So viewing a web page is not merely viewing a web page. There's so much information that is delivered to you by viewing that page.
It's what's coming in and what's going out. So you might have images coming from other websites, and you might be sending data out to trackers like Google, for example.
Yeah, that's completely right, and that is the case when you visit PassiveTotal.org. And even more so in this particular example, our application itself is a single-page JavaScript application using a specific framework called React. And that is a client-side framework, and what that means is when you view our web page and you look at the source, there's really not a lot going on there. Essentially what's happening is your web browser is taking that source information and then using JavaScript to essentially construct the application inside of your browser. So viewing the source is going to be completely different than the actual application itself. So there's a lot of changes that take place there that are very seamless and hidden to you as the user, but from our virtual users, we get to see every change that takes place.
So you get to see how it's constructed, all the links, the dependent requests, the cookies that might be involved, the certificates that are seen, all that information is stored and understood.
Absolutely.
So let's go on to the response and document object model.
Yeah, so this is a screenshot of our backend, and what this is essentially showing is just the raw content that comes back. So like I was just saying previously, when viewing the web page itself, viewing the source, the actual response body of the page, may be very bare and minimal, especially in a single-page JavaScript application like PassiveTotal.org. But once it's actually rendered out completely, there's a number of different changes that take place. So not only do we get the response body, we also get all the individual changes that take place as the web page is being built. And it's from this information that we actually go and derive some of the crawlers, where we're able to pull things out of the web page specifically. So the presence of a Google Analytics tracking ID, or the presence of specific links, or certain technologies that are running within the page. So it's that response body and document object model that really power a lot of these derivative data sets that we have. So one of the other items that we see as well, obviously if we're getting the response body and document object model, we're able to construct what links are present on the page by looking at the A elements for the HTML. And what we have here is just we're able to extract those components directly out of the page content. And I think it's worth noting too that we even have the XPath information. And what that is basically telling us is where that specific HTML element is occurring within the document object model itself. And if you're thinking about how this could be useful in the long run, how we can derive some interesting signals from this information, knowing the presence of, if a website was compromised, was the JavaScript injected in the head section of the page? Was it before the body? Was it after the body? Was it tacked on at the bottom of the body? There's a number of different pieces of information we can glean simply by looking at the location of certain elements. So naturally, when viewing a web page, there's a number of different network requests that take place. We're not just getting the content all from one server, or typically we're not. Now, you mentioned before that PassiveTotal.org might be going out to image websites, like it could be going to Amazon, like S3. It might be going out to Vimeo to get some of the videos, including maybe even this. If it's published on YouTube, it'll reference YouTube. In this particular example, what we have here, we call these concepts of going out to a third-party site or another part of the page dependent requests. And so in this example, we actually have the case where we were visiting http PassiveTotal.org, and our crawlers were actually redirected through a HTTP 301 response code to https PassiveTotal.org. We can see that GET request was successful as indicated by the 200 response code. And then we see that there's a dependent request that follows to use.typekit.net. And in this particular case, all we're doing is we're making a JavaScript GET request out to this third-party website in order to get a font. And so these become incredibly valuable because dependent requests help us shape a data set we call host pairs. The relationship between one website and another website observed during a crawl.
The child parent request, if it's coming in or going out.
Yeah. So we can see when you visit that web page, all of the other third parties that are being referenced, and then we can generally identify the cause that's taking place too. Was it a redirect? Was it a script reference? Was it an image reference? Was there an embedded video reference, and so on? So this information becomes definitely really valuable when dealing with potentially compromised web pages or web pages that are getting injected through maybe malicious ads.
And if you just went to the website and tried to figure this out just by examining the website on its own, you wouldn't see it. You wouldn't be able to understand it unless you had this crawl information to be able to go through and see exactly how it was constructed on the device itself.
Yeah, that's correct. Simply downloading the source of the web page is not going to necessarily give you all the dependent requests that take place, especially if some of those requests are handled through JavaScript. So downloading the source might give you some reference to third-party websites, but it's not going to necessarily show you how an ad is running or an ad being injected in the page and how it manipulates the structure of the page.
And it could even be obfuscated or encrypted inside of there that you can only get to it once it's rendered and you understand what's happening.
Yeah, that's when it becomes really powerful, that the derivative data sets that we'll discuss later, running the web page dynamically goes a step beyond. Static interpretation, there's a lot that we can do with it. It's certainly a valuable resource. But when you have the ability to dynamically execute a web page, you really understand the intent and what's happening behind the scenes. And so I mentioned before that our web crawlers go out and they're able to even maintain sessions. So we're not just going and downloading a single page. We're also going through and literally maintaining sessions in some cases. And cookies, small bits of information that are typically passed from the server over to the client, generally used for tracking state or maybe request information or describing the client. That's information that we get as well. And so in this particular example, we're able to see that PassiveTotal.org was displaying two cookies. One that is associated with our AWS load balancers, and two, something a third-party service that we use called Woopra, which just tracks usage of the application overall. So having these cookies is immensely valuable because the names can be unique, the values can be unique, and the path in which they were delivered to us can be very interesting.
So like even a marketing campaign, there might be a cookie that's dropped so they can track to see how that marketing campaign goes.
Yep.
And then even we've seen threat actors that might even drop the same type of thing to track how well their campaigns are going.
Yeah, or in some cases they might want to make sure that they're not delivering the same malicious payload over and over to the same security researcher. So by deploying that cookie and checking for the presence of it within, let's say, JavaScript, they know whether or not to deliver some malware. So it kind of goes hand in hand with some of our other data sets. As you can imagine, there's a lot of overlap between these. So last but not least, especially in this day and age where privacy is a big concern, we collect the SSL certificate information, assuming that it's present. So when we're going out and we're crawling a web page, regardless of the port, we will go and actually pull the SSL certificate that is delivered to us, including the full chain, and then we'll save that information. So I think most people commonly observe SSL certificates, or they know to check for the presence of them by looking for a lock inside of the browser. And then this particular screenshot that we have, it's just showing the certificate contents itself that is something you could see directly through the browser. For us, we're getting a data representation of this. We're not only taking note of the certificate and all the unique details, but we're also taking note of when and where we observed it, which IP address was hosting it, what domain was serving it.
And even the information inside of the certificate, the name, the country, the organization, all those are stored as well, so we can pivot off those and find relationships with that as well later on.
Yeah, that's correct. And we'll go into a deeper example and set of questions that you might want to ask when looking at this data set in the next session.